I want to call on our next speaker, Professor Stephen Moshier. He's a professor of geology at Wheaton College. He's done a lot of field work in the northern Sinai with Professor Hofmeyr. And he's currently working on the Leon Levy expedition at Ashkelon in Israel. And so I should add, while we're getting the slides queued up, that in the 3D visualization that you saw in the wave, we relied on Steve's GIS data to locate sites, so we wanted to have a consistent kind of link there. So, Steve.
Thank you. Okay. Can you hear me? I've got the lavalier on. Okay. Can you hear me out there?
Maybe a little higher.
Okay. Yeah. All right. I tend to vibrate a lot, so I wanted to make sure I had the lavalier mic on. All right. Can you hear me? Yeah. Yes, it is on. I could just hold it like this too.
Go ahead.
Okay, fine. Thank you, and I appreciate the opportunity to come and share the work that I've been doing with James Hofmeyr in the Sinai, and I'm very excited that this is kind of an act two to what Dr. Bitak had talked about last night on the physical geography of the Eastern Delta, as well as excited to see the visualizations that have been created here. I feel like I could have given this talk in the little cave you had in there, but there wouldn't have been enough room for all of us on the stage. So what I want to talk about today is essentially this area, which covers the area of Manfred Bitak's map that he showed us before, which encompasses the what we would call the Eastern Delta. And I want to talk about the kind of data that we're using to make these reconstructions, and also to talk about change. And to illustrate even modern change, I want to take you to this location here. I apologize, I didn't realize we were going to use the most high-resolution projector in the world, so I should have rescanned many of these images. But actually, this is a remarkable Cold War era spy satellite image from the Corona program. These are now available on the internet for purchase from the United States government. But these images were taken in the mid-60s, and they show the ground as it was before development. And as you'll see, this is very useful data in reconstructing the geography, even going back to the Bronze Age and earlier. So let's look at what it looks like today. We can see that there's been extensive agricultural development and urbanization in this part of the Sinai and the Suez Canal zone. This is the Suez Canal right here. And in many ways, Jim Hofmeyr was very fortunate in getting to the site at Tel Borg when he did, because it really was a salvage operation, and that here's the location of Tel Borg, but it was about to be completely demolished in the attempt to create a large agricultural area. But then that also had some positive benefits, which I'll describe. If we want to go back to why we even have a Nile Delta, we can use the data from the Smithsonian drilling program under the direction of Jean Daniel Stanley, which was featured in the 3D visualization yesterday, or ongoing. If you haven't seen it yet, please go look at it. These are a number of cores that were drilled in the mid-'80s, early '90s. And I'll show you a core here from out at Port Said at the edge of the delta. And what we see is that the Nile really starts about 8,000 years ago after the end of the last glacial. And out there at Port Said, we have about 50 meters of deltaic sediment as the deltas built out over time. And this is actually true for all of the modern deltas of the world. They have a similar origin. And something to keep in mind is that sea level is rising at this time. So here we have a sea level curve. And even for us to keep in mind that in the late bronze, sea level was probably a meter or two lower than it is today. So these are things we need to keep in mind when we're reconstructing coastlines and such. Now, from this wonderful data, Stanley and others made some very cartoonish but very useful reconstructions of the development of the Nile. And here we see what it may have been like 8,000 years ago as sea level is rising rapidly after the last glacial, after the northern hemisphere ice, continental ice sheets had melted. And so you can see that sea level is a little bit further out than where it is today. But the various branches of the Nile are now beginning to build out. By 5,000 years ago, the Plusiac delta cone is beginning to form. And this is at about the time that the sea level rise is stabilizing, so that it was going from a very rapid rate of rise to just a couple of millimeters per year. Now, if we get to about 3,500 years ago, which would be sometime in the Bronze period, we would see that the Plusiac Nile is beginning to build out in front of what had been the coastline through much of the early Holocene period since the end of the Ice Age, and that period of sea level stabilization about 5,000 years ago. And by 1,500 years ago, we can see how the Plusiac Nile has essentially silted up, and now the Tenitic branch is building out. And we see a lot of real estate out here in front of what was the Bronze Age coastline. And if we go to this area a little more closely, we can see that. This is the same set of corona images. The sites, well, first let me point out this rather straight line. When a geologist looks at something that long and that straight on the Earth's surface, it's either a coastline or a fault. And in a way, this is both. It is identified as some kind of buried structure. It's been called a transcontinental megashear, but it basically is an important structure that probably controlled the coastline of the Bronze, up through the Bronze Age before the Plusiac Nile started building out. And we can see that with the distribution of archaeological sites. North of this line, which is called the Pelusium line, we find only Roman and later sites. And then south of that line, we find just about every age imaginable: Egyptian, Roman, Said, etc. So it's a really important feature, and I believe we can show with our field work and our work with these satellite images that a lot of the coastal geology, the coastal sedimentology of that area is preserved. And we can make a very detailed reconstruction of the geography of that area. Now, we're not the first to do that. Here's a map from Bruno Marcolongo. I believe he was working with the French expedition at Tel Hair. And this is based on some satellite imagery and probably some field work to identify this spot back here, this dark area back here, as a paleo lagoon along the coast, an ancient lagoon along the coast, and then some ancient dune ridges that existed along the coast, sort of like a barrier island, if you will, in front of that paleo lagoon. And of course, this was also depicted on the map that Dr. Bitok showed last night on the far eastern extent of his map. Now, here's Dr. Bitok's map, and I apologize for the low resolution of the scan. But this is an extraordinary contribution to our knowledge of the geography of that time. He has the Bala lakes depicted, and this paleo lagoon here, and this coastal ridge, and then the open sea out here before it is filled in with the advance of the later Plusiac Nile branches. But what I would like to do is focus on, in more detail, on the surface geology in this area to try to give us even more constraints on the geography in this area, if it has any bearing on the route of the Exodus. Well, let's go back to where we were working. Jim and I I first was out in this area with Jim back in the late 90s, and we were interested in this interesting double lineament here, which had been interpreted by some Israeli geologists in the 1970s as some kind of an ancient canal system. Of course, you can see other scars in the land which could indicate some kind of buried canal or channel system. Maybe Jim will talk a little bit more about that in his talk. But we never did excavate this to confirm the age of this system. There turns out that there are many of these double tracks around. They also resemble holloways in a bit of a geomorphic sense. But nonetheless, we were taken to Tel Borg, where excavations began in 2000. And my opportunity was to look at the surface geology in the area and to take advantage of this agricultural project. As you can see, we mapped these irrigation canals, which allowed for us the opportunity to see into the subsurface down to about 2 to 3 meters without having to drill a single hole or to do any drilling. So it was a salvage operation in a sense, but it also was an opportunity geologically. So we used these corona images that were georeferenced to GIS for base maps, and we logged our positions with GPS so we could have very precise locations of our collections to make our maps. We came up with a basic stratigraphic model which has basal Pleistocene sand, which is overlain by muddy deposits that are Holocene in age and dated by carbon-14 of shells, which were deposited, and some wood at the Tel Borg site, or carbon at the Tel Borg site. So I'd like to walk through some of these environments. Here's a map we made of these muddy Holocene deposits. These are contours showing lines of equal thickness in meters of the mud. And this gives you an example of what we're looking at along these irrigation canals, open canals. Here's a thin muddy deposit on the basal Pleistocene sand, and you can see it pinching out right there, and that's that spot there, that zero line. So there's this little mud puddle that goes from 0 to about 2 meters in thickness in this area. This is the location of Tel Borg. And then, of course, we could get some sense of the age of the deposits by looking at the carbon-14 dates of some of the shells. So that would be from this location. And we also were able to confirm the thickening of the mud into the Paleo Lagoon. Unfortunately, there weren't opportunities to get any deeper than about 2 meters by looking in the canals, but certainly increasing thickness in this direction, and very nicely developed shoreline preserved especially along the eastern margin, and a little more diffuse along the western margin. We also had the opportunity to look at some of these coastal dunes, and unfortunately, there are not many of them left. They've been pretty much destroyed in this agricultural project, but it did have the opportunity to photograph the nice cross-bedded sand, very typical of a windblown dune deposit, and then also sampled some of the shells in contemporary or older mud, giving us a date of about 6,000 years before present. So I believe this was the coastline, which was fairly well stabilized throughout the Bronze Age. Also examined a number of fluvial features, and this confirms the path of the Plusiac Nile that is on Dr. Bitok's maps, flowing from Piramesi toward Hebwa. And you can see on the photograph here some lenticular very much fluvial bar-like features. And unfortunately, all of this was completely plowed by the time I got there. So there's never any opportunity to go out and look at these alluvial bars. Although excavations between Hebel 1 and Hebel 2 have shown that there was some kind of a channel there, lots of discovery of fish scales and fishing instruments. And so certainly agree with placement of a channel here. But looking at the photograph, we also noticed some meandering features here. And we're able to confirm another channel, which was unknown, and probably also, well, I believe, related to the Plusiac system. Here's an example of where this channel is exposed in a large open canal that was dug for the agricultural project. And so you basically have this basal Pleistocene sand on both sides with a great big plug of mud in it in the middle. That would have been at this location. And at Tel El Borg, this is the site of the forts at Tel El Borg. Here we're looking towards the southeast in this view. The channel is a good 100 meters wide. Could have been as much as 4 meters deep, although there's been a lot of deflation, plowing, and excavation around here where we did the trenching along the channel here. But here's a cross-section showing the different sedimentary deposits. Lots of pottery discovered, New Kingdom pottery, dates from charcoal and shells, which put us in the 3,200 to 3,500 years before present range, but then also pottery all the way up through to Roman and Hellenistic at the top. So I believe this channel was active for a long time. It may have been canalized perhaps in the later stages to allow for some transportation between different sites by canal, although I don't have direct evidence of that. It does seem to make some sense. What I wanted to point out were some of these sands had loading structures on them. For the geophysicists here, this would be potentially evidence of seismic activity, because these wet, sandy sediments during shaking would have liquefied and created these little ball and pillar-type structures or flame structures, which are very diagnostic of earthquake activity. So it certainly would go along with a lot of, not a lot of, but occasional seismic strong activity in that area. This just shows how the channel sands are much coarser than and much more poorly sorted than the basal Pleistocene sand or even the modern dune sand today. And one of the things that we found very interesting was that in the earlier outline of the fort, the entire side was missing the moat system there, the foundation system, and you could see that it was completely truncated. And my interpretation is that these are high energy fluvial sands that would indicate flooding, which probably resulted in the abandonment of that structure because it was built too close to the channel. This is some surveying. 1 and 4 are from the axis of the channel, and then 2 and 3 are from the margin there at the edge of the fort to show the nature of the deposits. I would interpret them as being a combination of high energy sands during high flow periods, but then when the flow is much lower, there would be more of an estuarine kind of situation as this river or channel is flowing into the Paleo Lagoon. Now, we're able to trace this some distance. Those last two sections were from the Tel El Borg site and then a construction pit about 3 kilometers away. And I believe we can trace this even further down into the Bala Depression. So here's our original paleogeographic reconstruction of this area. But we wanted to extend our study down into the Bala Depression because of the interest there in its importance in the Eastern Delta region. So for a couple of seasons, I'd have a couple of weeks a year to go over and work with a geologist colleague, and we used a very crude drilling method because we didn't have the irrigation canals here. Incidentally, this is evidence of the Reed Sea crossing at that point, and this is evidence of what happens when you're not careful. But we were able to do some drilling and surveying. This is along the really well-defined shoreline of the Bala Depression, a survey out about 300 meters, and you can see that we dropped down about 6 meters in elevation, and I expected probably go out to maybe as much as 10 to 12 meters out further in the area of the depression. And you can see some of the carbon-14 dates are getting us down into some of these muddier deposits down into the 3,000 before present range. And then also drilling out in the area south of Abu Seifa, which is a Roman site with boat slips, clear evidence that there was a lot of water in this area even through Roman times. I was surprised. I expected to find a great big lake that would just be filled with mud, and really it was quite spotty. There were muddy, loamy, and dirty sand and clean sand deposits, really almost randomly scattered. I'm still trying to make some sense of it. Carried it down to the western side of the Suez Canal area and the southern part of the depression, and found many more of these fluvial type sands, very coarse sands, including containing Nile catfish scales, and a mineralogy that is very consistent. Okay, thank you. Very consistent with a Nile source. There really aren't Sinai sources in this drainage regime that we could call on to explain these mineralogies here, including the feldspars, which look like they may have come from some of the basalts that are in some of the more northern cataracts. So we traced I believe with confidence we've traced this branch down through the Bala Depression, but we wanted to look at where it would connect to the rest of the delta, and we looked at some work that had been done with remote sensing and duplicated their work because they were able to correlate the sediment textures with these band signatures. And so we did the same thing that had been done in the plain of Tino in this area, and we found that some signatures of ground that are very similar to what we find in other parts of the delta. Didn't have an opportunity to do any groundwork there, but I did do some hydrological modeling where we used the geographic information system to use digital elevation models to determine surface flow paths. Using the space shuttle radar data digital elevation model, it was interesting to see where the computer would draw the flow paths. Used the Aster, another satellite data system, to try to look for flow paths. They weren't terribly satisfying, so I essentially hand digitized all of the contours up to 10 meters in this region and found out that they're essentially the same contours on Dr. Bitok's maps. And so we're probably using similar data from the old British survey maps. And then asked the computer to do that. And we see remarkable correspondence between Dr. Bitok's maps and then my proposed route. So if we look at the confluence of flow paths from these different digital elevation models, I think it's reasonable that there could have been flow out from the core of the Nile, if you will, up into this direction. So here's a combination of shuttle radar digital elevation data plus the hand digitized contour data to show a possible route of this system, which I would say would be maybe an older, earlier Plesioc Nile system that was in some way active at least through the time, probably the 20th dynasty where we have evidence of it at Tel Borg. And then to take it to the whole area of Dr. Bitak's maps to just add this new channel. Here's a perspective looking from the east towards the west, P. Ramesses. So I believe this gives us some more physical constraint on the geography of that time. And so my conclusions are that the Holocene deposits in the study area delineate fluvial deltaic environments associated with the defunct Plusiac Nile River, including previously unknown channels. Geological survey provides paleoenvironmental context for Bronze Age archaeological sites, the Ways of Horus route, and early Exodus path in the North Sinai, and that future work should, of course, involve field survey of these proposed channel locations based upon remote sensing predictions. Thank you.
Great. Yeah, we have time for questions. I've got a quick one. When you reconstruct the coastal environment in terms of the swamp, my impression it's like a swamp-like setting. Could you elaborate a little more about what kinds of plants might be growing there and how deep the water may have been in that place?
Well, I'll use this now because I think there's a conflict between these. This is very close to sea level in this area. In fact, I kind of had to use a combination of data to decide where the coastline is. I don't know if we can be completely sure, but it's very, very wet in this area, in this whole entire area. And there are places even today that are at sea level in the Bala Depression. So you're like I said, I think that during a full, high flood, high discharge event, this certainly could have been completely inundated. And other times there were probably isolated lakes and ponds. But in terms of the botany, I'm not really familiar.
There's a question over there. Got to say your name.
Still Ron Hendel. I want to expand on some of the comments I made earlier. If this is in some ways about the Exodus itinerary, some sort of geographical limitation or constraints on what the Exodus itinerary is, I simply want to note, since I don't know anything about geology, but I do know something about the Exodus itinerary. Mm-hmm. It's a text in Exodus and Numbers, and it's a series of small texts that was either written by or used by the P source. It seems to me that the initial, to construct a cogent scholarly analysis of this concept, one has to start with the text, talk about its cultural context, its narratological functions, its authorial and literary style. And then if one wants to talk about the relationship between this text and history, then one has to do it seems to me that the correct way, I submit that the correct way to go about this is what Professor Osman calls mnemohistory, that this is cultural memory, and one needs to consider all of the different streams of interconnection, the kinds of folklore motifs that Bernie was talking about, the attempts even of the P writer to do a kind of antiquarian reconstruction of what such a passage could have been. The P writer likes to produce what Roland Barthes called the reality effect. This is what happens with the genealogies, this is what happens with the dates, this is what happens with these place names. The P writer likes to fill in a sense of detail that expresses the passage of time, that in this case expresses the passage of geographical space. So there are literary, there are cultural, there are mnemohistorical parts of this. a place called Ramses, as Professor Bitek said last night, probably is a reminiscence of the prominence of these P. Ramses in the late Bronze Age. So there are lines of historical memory that flow into this. But I think to go from the text immediately to geology is, in a modern context of critical scholarship, intellectually indefensible. Thank you.
I don't know if that was a question directed at me, because the only reality I deal with is mud and sand and sea levels. So,
Poor guy. I mean, boy.
I think, though, that it is a legitimate thing to look at the geography at times that are pertinent to the question, and certainly pertinent to the issue of the geography of the New Kingdom of Egypt or the Old Kingdom of Egypt. So it really, hopefully this is an objective study. I have no agenda on, what's going on there with respect to this itinerary, other than that there are bodies of water and there are coastlines. So.
Yes. It's Manfred?
Yeah. Thank you very much for this fascinating study. And I think it's absolutely legitimate and even cogent to try to find the physical background of what is possible and what is not possible. And if you would like to study if there are some memories going back, for instance, into the New Kingdom or into the Third Intermediate Period, this is the foundation of such a study, and I think it's most important. What intrigues me is this easterly deviation of the Pelusiac branch of the Nile. I wonder how it could be dated, probably by settlements along its banks. What would be very important is to map also ancient drainage systems. I miss here the Bahr el-Baga drainage system, which is it's more to it's nearer to Tel Dawa. The Bahr el-Baga drainage system, which was a barrier of swamps and overflow lakes. And I think something like this is as important as waterways, active waterways, because depressions create a very specific habitat and swamps, which show us the limitations of and also the limitations of roads or paths which could be used in ancient times. Of course, the most important problem to be solved is how to date such waterways. I mean, you used radiocarbon recently, also stimulation, optic stimulation of grains are used, which is a very rough method still. But I think there is a good progress going on. I'm very intrigued by your study. Thank you very much.
We still have some time. We're gonna go for lunch at 12. So, if there are any other remarks, questions, if not, we'll break, and then. But the lunch won't actually be served till. Oh, it is ready. Okay, let's eat. All right.